Hey folks, this is Cap Jones here to give you a basic introduction to this program called Logisim, which we're going to use in Lab 1 to start to make a simulated LC3 computer. So once you download that program and you have Java, when you open it up, it should look like this. And so I've got a little kind of grid pane as the main window where I'm going to drag and drop my components, and then a whole bunch of tools on the left-hand side that are going to allow me to build some circuits. So the menu here that you can kind of see, which is sort of like a folder structure, is effectively my full library of components. And so I would pick stuff on here by like clicking it once and then sort of placing it onto my my screen here, and then I can drag them around and that sort of thing. I can highlight a bunch at a time and delete it if I want. And I've got some components up here that are kind of commonly needed. So this is an input button, an output button, and then I got three logic gates, not, and an or. Okay, so if I click that and bring it out here, I wire connections by clicking and dragging between components, or between like ports. I can clicking once doesn't work. If I want it to go a specific way and I don't, and the software is kind of auto routing it, then I just have to sort of, might not need to do this in multiple steps if that's what I want to do. But I can wire my two inputs here to my OR gate. I can wire the output of the OR gate to my output here, and with a little circuit like this, then I can start to play around with these values. If I switch from my selection tool, which is the arrowhead, to what's called my poke tool, which is the little finger, now I can start toggling these values, and you'll notice here, of course, that OR gate is functioning the way you would expect it to. When there's at least one of the inputs is true, then the output becomes true. Part of the reason this works is because under the simulate menu here, by default, the simulation is enabled. If I want, I can disable the simulation, and then clicking stuff doesn't make any change to my circuit. And if I've ever found myself in a place where I want to sort of start over, then I can click reset simulation, and that'll set me back to sort of my initial state. Or I can press Control R. I'm pressing Control R on my keyboard right now. That'll take me back to the initial state here. This OR gate's looking a little funky, so I'm going to go back to my selection tool, and I'll bring to your attention the fact that when I select a component down here in the bottom left, I get a whole bunch of features about this component that I get to change. Number one might be the number of inputs. So right now the default here is 5. Let's change this to 2. Okay, so 3 of my inputs went away. If I want, I can change the size of the gate here from medium to narrow to make it a little smaller. You'll notice now I got a little error on my output because I'm not sending anything to my inputs here. And if I want, I can give this a label. Okay, and sometimes that's useful to help you differentiate components. If the orientation of this gate's not really working out for me, I can go to the sort of facing option. Instead of facing it east, I can maybe, let's say I'm going to face it north. Okay, so now again I have to reroute these signals, but I can use that to change the direction of my gate. And maybe that label is kind of getting in my way. Let's see. Oh, nope. Sometimes I'm able to change the position of the label, but maybe not on this one. Okay. Other components will have other features. For instance, a big one that we're going to kind of manipulate in this course is if I click an input here, I'll have the number of data bits that it's sort of controlling, right? So, so right now this is just a 1-bit signal, but if I want, I can make this go up to 4, and now I got 4 bits potentially that I can sort of use my poke tool to kind of toggle on and off to change this value. All right. So that's the basics of kind of drawing stuff and simulating it. Now what I want to do is show you a couple of really key components that you'll use probably a lot in this lab. Number one is this thing right here. It's called a tunnel. You'll find it under the wiring folder, tunnel. And all that means basically is that we're going to give a name to a signal. And then anywhere else I use that name, you can see down here I've got another tunnel or label with that same name. Then wherever else that sort of label is, the signal pops out. And so that can, if I've got signals that are like going all the way across my circuit, and rather than try to have to route a wire from one end of my screen to another, I can instead make a little tunnel. So an example of using this might be I'm going to put a little input here. I'm going to change the the direction so that it's facing west and wire these together. And then to kind of observe the output down here, I'm going to go down to the second to last folder, input output, and grab a little LED. You shouldn't have to use these too much in the lab, but this is useful to kind of show what's going on. With my poke tool, then I can toggle this signal on and off. And you can see, of course, the LED turning on and off because it's connected by this label. All right. Like with a lot of other components, I can change how many data bits are being tunneled. As well as that name. It's my understanding that it's case sensitive, so it's just the the actual text name that's sort of matching these tunnels. If I've got signals that I want to sort of break out, multi-bit signals I want to break out or sort of combine or something like that, then I'm going to use this tool called a splitter. So the splitter, when I select this, lets me choose how many bits are coming in and how many wires are coming out. And then I get to map those wires to as I want to the ones that are coming out. So this is an example of taking something like a 3-bit signal that's coming in and sort of breaking it out into constituent components. So to kind of demonstrate this, I'm gonna add another input. I'm gonna make it a 3-bit input, and then I'll add 3 LEDs to just kind of observe what's going on with this input as I have it split out. So now all zeros coming in. If I change this lower least significant bit, that's my 0th bit. So now you can see the 0 LED is turned on because this is on. If I turn on my 3rd one, that's bit number 2, then this is now on. So this is, if I've got a multi-bit signal, this kind of helps me break it apart. Another example of using the splitter is right here where I might have, let's say I've got 5 bits coming in. I want one multi-bit wire coming out, but I want to take a little subset of those 5 bits. So all I'm going to do is down here where I'm assigning the bits, I'm going to make the bits that I want come out to that numbered wire, that 0th wire, and I set the other ones to none. So this is an example of taking a 5-bit signal and going down to 3 bits. Let's see if I can get a little example of this working here. Okay, so recall again that I've got it's the uppermost bits that are being sent, that are sort of being carved out and sent down to the other end of the splitter. So you can see here I can set these to 1s, and those are all getting sent down here. If I change these lower 2 bits, nothing happens. So I can use that splitter also to sort of carve out a multi-bit signal. Down here is a component called a register. So you'll find that under the folder for memory. Anywhere where I need to sort of save a value, I can put a register here. And so I can change how many data bits are being saved in that register. I can change whether it's rising or falling edge, and I can give it a label if I want. D is my input and Q is my output. And then the other 3 signals I've got here are my clock, which is this little triangle. The label, or sorry, the pin that's next to the 0, which is like your reset. It's like your clear. So when this is when this is a 1, then the register gets set to 0, and then I've got my enable pin here. So as long as that's a 1, the register takes a new value. If it's ever a 0, the register sort of holds its value. All right. Up here is my multiplexer, and I've got an example. I'll show you how to use that. You can find that under the folder affectionately titled Plexers. So recall that a multiplexer is something that lets me choose which signal I want to send to my output. Okay, so I'm going to wire this up. We'll just do 2 1-bit inputs for now, and I'll change this so it's north facing. By default, the multiplexer has an enable pin, but I usually don't. I don't really need that most often, so I'm going to turn that off. I'll wire my select signal here, and now my 0 signal is 0. My number 1 signal is on. This is going to select which one is going to my output, whether it's my 0 or my 1. Now the multiplexer's got 2 little fields here. The select bit 1 is controlling kind of how wide the select signal is. Right now it's 1, and that means I can select from 2 inputs. If I were to change this to like a 2, then I could be able to select from 4 inputs. Right, 2 to the squared is 4. Data bits has to do with how many values are being passed through. So I could make these, let's see, I can make this a 5-bit inputs. Logisim's going to warn me that there's a mismatch between those two. That's fine. I'm going to change this to a 5 and this to a 5. And now I've still got one select bit, so I'm only selecting between two of these inputs, but each input is 5 bits wide. So you can see that here. Okay, so you'll use multiplexers quite a bit. All right, next is a component that just extends a grouping of bits. Okay, so you can find that under wiring bit extender. That will show you this thing here, and that's useful because again, you just saw that Logisim is very cautious about how wide multi-bit signals are. So if I've got 4 bits that I want to send to something that is expecting 8 bits or something like that, then I need to somehow extend or pad it. So let's say I've got let's do that. I'm going to change these widths to be 4 and 8. All right, so I'll put a 4-bit input here, and then we'll do an 8-bit output. And the last field in this extender is what type of extension I want. Right now I'm 0 extending, so that means these lower 4 bits should be replicated in the lower 4 bits of this this 8-bit field, and the upper pieces should all be zeros no matter what this value is. So you can see that the result here is kind of being padded with zeros. Right? The other one you'll use really is not 0 extension, but sign extension. So recall that as long as if we treat this 4-bit number as a signed value, then effectively this most significant bit dictates whether or not this is positive or negative. So what sign extension does is it'll take the most significant bit on the input and then propagate it throughout the whole output. So you can see here, if I change this to a 1, all of the most significant bits got changed to 1 because that 1 here was propagated through the whole output. All right. Okay, lastly, we've got this component here, which is a nice adder. So you can find that under the arithmetic folder. The first one here is my adder. The only field I can change on here is how wide it is. So if I make this, let's say it's 4 bits, then what I can do is add a couple of 4-bit inputs. Typically, I don't need to set the other pins, which are my carry in and my carry out. They're just sort of off or 0 by default, or at least the carry in's off by default. And this is just going to perform the arithmetic addition. So 1 plus 0 is 1, 1 plus 1 is 2. That's a component you'll use quite a bit. Okay, that's all I got for an intro to Logisim. The next video I'll show you is going to be introduction to the actual circuit you'll be working with. So that's all I got today. I'll see you next time.